At 60 kilometers down, Jupiter's sky glows like a furnace, and there is still nothing solid beneath your feet. In plain words, Jupiter has no solid surface to land. A fall here is a tour through layers, not a landing. You would see colors change, winds howl, and lightning bloom. The deeper you go, the stranger the physics becomes. By the end, the air itself turns metallic and crushing. So let's start at the cloud tops and drop. The planet swells in the window, banded, enormous, and alive. Falling into Jupiter means crossing its cloud tops, then sinking deeper. That is the simple picture, but the scale is wild. You approach a world wider than 11 Earths, edge to edge. Gravity here is about 2.5 Earth-g. That pull makes speed rise fast, even before the air. Your path curves into night and day across endless stripes. Cream, ochre, and rust bands slide past like flowing rivers. The great red spot sits like a hurricane the size of Earth. Its shape drifts slowly, while smaller storms spin and merge. Why care about this approach? Because speed and size decide everything. The view is gorgeous, and the physics is ruthless. Jupiter's gravity makes even small errors become violent heat. The air is thin up here, but not for long. Molecules thicken, and drag begins to nibble your energy. Rule of thumb, double the speed, and heat goes quadruple. That is why entries get bright before they get loud. You would see the limb glow as RAM air compresses. Faint auroras flicker near the poles, like curtains of jade. Your instruments tick upward: velocity, dynamic pressure, radiation dose. Example in real terms, Galileo hit at 47 kilometers per second. That is New York to London in a minute twice. Your fall matches that order if you drop from orbit. Net result, the beautiful disk is now a hungry horizon. Fire blooms around the heat shield, even in thin air. Entry plasma forms when compressed gas gets hot enough to ionize. That just means it glows and tries to eat the shield. This part matters because heat is the first gatekeeper here. Without armor, you do not see anything beyond this wall. Flow meets the shield, slows hard, and forms a shock. Molecules break, recombine, and radiate orange and violet light. Ablation layers char, foam, and peel away in smoky curls. Sensors record a brutal deceleration spike, even before thick clouds. Galileo felt about 230 G during its fiercest braking. Your eyes would not see Gs, but you would feel them. Blood pulls downward, vision narrows, and colors flatten at the edges. Then the glow softens, while the roar deepens into thunder. The sky goes from black to bronze, then milky yellow. Shapes appear: torn cloud shelves, rolling waves, and dark chimneys. These are convection towers feeding the belts and zones. Winds shear in opposite directions, stacked like sliding decks. One sentence gist: heat buys you minutes of sight. Example in real terms, the shield mass is spent to save sensors. Every kilogram evaporated keeps electronics cool a few seconds longer. Bottom line, surviving the glow earns you a seat inside. Clouds open into layers, each with its own mood and palette. The top deck is ammonia ice, bright and almost chalk white. Falling into Jupiter means threading these stacked decks like endless weather. It matters because every layer hides new chemistry and new wind. Motion here is not random, it is organized into jets. Fast eastward bands alternate with fast westward bands like conveyor belts. Vertical plumes punch upward, while dry downdrafts carve clear lanes. Shear tears curls into scimitars, and waves run along boundaries. You might cross a belt front where wind flips direction abruptly. That snap can toss a probe like a leaf in rapids. Meanwhile, chemistry paints the scene in creams, beige, and butterscotch. Deeper, ammonium hydrosulfide gives amber and brown tones to clouds. Below that, water clouds thicken into towering thunderheads. Example in real terms, wind speeds exceed 100 meters per second. The view feels slow, but those flows are highway fast. Lightning scars fade into view as ghostly, vertical streaks. Holes open to reveal deeper, darker, warmer levels below. Fine hazes hang like smoke, softening edges and swallowing distance. So the picture is a stacked atmosphere, restless and sculpted. The storm belly flashes and the clouds become X-rayed veins of light. Lightning here fires deep within water clouds, not only the top. That means flashes backlight towers and reveal hidden structure briefly. You care because lightning tells you where water is busy. Charge builds as ice, graupel, and vapor collide in updrafts. Collisions trade electrons, and electric fields ramp toward breakdown. When the air finally yields, a leader threads a conductive path. A return stroke surges, turns night to day, then fades. Some bolts on Jupiter carry energies beyond Earth's wildest storms. Radio bursts and optical peaks suggest superbolts by an order. Example in real terms, a single flash can light hundreds of kilometers. The scene is eerie because the light comes from within. Shadows flip direction and clouds glow like paper lanterns. Tiny test, close your eyes after a flash and wait. You would still see the afterimage floating and slowly shrinking. Raindrops hiss in the distance, but sounds arrive muted. Pressure is higher and sound dies faster in the haze. Net result, lightning exposes architecture you could not see. Now the hail starts, and it is not like Earth hail. Juno saw evidence for ammonia water mushballs forming inside storms. Falling into Jupiter means dodging slushy, icy cannonballs in the dark. You care because these pellets move ammonia deep, changing the chemistry. They grow where ammonia dissolves water ice in cold updrafts. The mix turns slushy, heavy, and sticky, perfect for grabbing more ice. Pellets rise, fall, and cycle until they become dense projectiles. Then they drop out and sink through warmer, drier levels. As they fall, they carry ammonia to depths clouds cannot reach. That changes where lightning forms and where colors show up. Example in real terms, sizes may reach grapefruit to volleyball scale. Speeds reach tens of meters per second in thick air. Impacts would sound dull, like sacks hitting a gym floor. Visibility would drop as ice mist and shreds drift everywhere. You might see shards tumbling past, rimed and dirty beige. Winds would push curtains of pellets sideways, like sideways sleet. Bottom line, mushballs are couriers delivering ammonia to the deep. Let's check our only real descent diary, written by the Galileo probe. It parachuted for 57 minutes before failing in the heat. Falling into Jupiter became real data, not only imagination, that day. This matters because it anchors what the layers actually felt like. The probe reported pressure rising past 22 bars. Temperatures climbed to about 153 degrees Celsius. Winds topped around 170 meters per second. The onboard camera died early, but other sensors kept talking. The parachute cut away as air grew too dense. The probe then fell faster into hotter, darker air. There was no splashdown, only silence as systems overheated. Example in real terms, the depth was roughly 150 kilometers. Instruments tasted ammonia, water, and hydrogen riding upward in plumes. Radio signals thinned as the thickening air absorbed energy. What to remember, we have a map we can trust from Galileo. Deeper still, hydrogen stops acting like a familiar gas. Under immense pressure, it turns into a conducting, metallic fluid. Falling into Jupiter becomes a plunge toward a strange, dark ocean. You care because this stuff may power Jupiter's magnetic field. Electrons move freely here, so currents can grow and twist. Those currents help build a dynamo that sustains the magnetosphere. The scene would look like black mercury, rippling under crushing weight. Temperatures here are thousands of degrees, hot enough to glow faintly. Pressures climb toward millions of Earth atmospheres, far beyond lab steel. Your lights would reflect as streaks, then smear into shimmering bands. Sound would barely travel because density and gradients kill waves. If you could swim, your body would be a bubble. But you could not swim, every material fails at these conditions. Example in real terms, pressures reach about 2 million atmospheres, depths past thousands of kilometers, with no solid floor anywhere. Heavy elements likely mix into a fuzzy, diluted core. Bottom line, there is no ground, only stranger, denser phases. You began with no ground to hit, and that held true. The sky just thickened, heated, crackled, and then turned metallic. That is the loop closed from clouds to a black ocean. If you want more trips like this one, stick around. I make space explained in plain pictures with calm beats.